Hi, welcome you all once again for the session Polymorphism in Object Oriented Programming. Before getting into the polymorphism, we should understand the type of an instance or type of an object. Each variable has a data type. It may be primitive data type with respect to integer, float, double, string, etc., or non-primitive data type with respect to class, object, string, array, interface. Here, for example, we are declaring the variable with respect to integer data type. We are assigning the value 30. So here the variable is type of integer with respect to primitive data type. The references have a data type like class, which is defining with name animal, then public static void main method. In here we are defining the object, so this is a type of animal class. So here object is having a reference with respect to the class animal. Objects also having a data type like object is an instance of the class, but it is also an instance of its superclass, that means parent class. Here for example, the animal is in class. Here inside the animal class we can have set of statements. Then we are defining the child class to the extension of the parent class animal. Inside the animal inside the dog subclass, we are defining the main method. Then here we are creating the object with respect to the child class dog. So here d1 is the instance or object of an child class dog, and also which is an instance of the parent class animal. So here we can define the data type for the variables are with respect to the references of its class and object. So here the polymorphism is creating the binding between the method call and method implementation. Method call in the sense inside the main method, right, inside the public static void main method, then we will pass a string and set of arguments, etc. So here we will define the object with respect to some class, for example animal, then new the class name animal. Then here we will use the object and call the method. For example, suppose if we are having the method add, we will call this method like that. Here the if this animal class is having any method add, then here we will define some set of statements. So this is method implementation. Here this is method call. So the polymorphism is creating the binding between the method call from inside the main method and the method definition which is defined in the parent class or any child class or in its own class. So here the poly is representing many and morphs is representing forms. So the many forms of methods will be available with a similar name. So here that is the name polymorphism is representing. Object can have many forms. Okay, that is the thing here. Objects can be resolved during the compilation time or during the runtime. Based upon that, we are having two types of polymorphism. One is compile time polymorphism, which is also called static binding or earlier binding, which is creating the link between method call and method implementation during the compilation time of the program. The type of an object is determined during the compilation time by the compiler. Runtime polymorphism is second category, which is also called dynamic binding or late binding, which is creating the connection between the method call and the method implementation during the runtime. The type of an object is determined during the runtime of our program. And the compilation time, in the sense we will compile the program by using the javac command, that is the compilation time. Then we will run the program by using the java command, java, then program name, program name dot class file. Okay, program name will be executed here. Java C program name dot java, it will be compiled. So this is the compilation command. This one is a runtime command. And in static binding, the actual object is not at all using, but the actual object is used during the dynamic binding of the program. Here the compilation time polymorphism is giving the method overloading or operator overloading. So it can be achieved by in these two methods, but the Java programming is not supporting the operator overloading. So to achieve the polymorphism, the only approach for the static binding is method overloading. The method overloading in the sense here, more than one method in a class having same name but different type of arguments or different number of arguments. For example, here we are having the class test. This test class is having two methods, method 1 and method 2. So method 1 is having the name add, right? Then it is having some set of statements like that. Here second method is also having the name add. So both are similar names, but here there is no arguments. In the bottom one we are having the argument a with respect to integer data type. It is having its own number of statements. So here the method name is similar, but which is different with respect to the number of arguments. All right, so that's what this one we are having the scenario here. And next one is changing the type of the parameters. Here class name is test is defined, and it is having two methods. One is void add float variable a, and which is having some set of statements. Here method is completed here, and second method is defined here. This is having integer a. So you see both are having one argument here, but the data type of the argument is different. So first method add is taking float variable a, the second method is taking integer variable a, but both are having similar name add. So here the polymorphism, that is method is having different forms, many forms with respect to the type of the parameters. So here we are getting this constraint into this scenario, right? Next one is changing the order of parameters. So here also method is having add name, and here also method name is same add, but the order of the variables, here also a with respect to float variable, here b with respect to integer variable. Both are local variables here, and here we are defining two number of variables, so count is same. Okay, so here the second constraint is not enforcing, but here the type of the parameter, okay, the type of the parameter, first variable type is float. Here in the second method is having first variable type is integer. Like that, in the first method second variable is integer, but in the second method first variable second variable is float. So the order of the data type is varying. So here the different type of arguments, here we are passing in the same method name. Okay, method names are similar for this two methods. So here the method is having same name, but which is varying with respect to data type of the variables. So methods are having many forms. Okay, and here we are giving and one more thing here, the third point, private and final and static methods in a class uses only the static binding, because we cannot possible to override this variable, methods. Okay, we cannot override this final method or private method or static method, because we cannot change the value of this final method and static method, and if you define the method as a private. And here this examples are not following the method overloading. The class name is test here, and method name is both method name is add, and here also no argument, here also no argument, so both are similar. And here this is having a different data return type. Okay, return type is different, integer. Okay, but here it is void, so both are not similar, similar implementation. So this is integer return type data, this one is void. Okay, so both are not similar, so which is not yeah, same methods. Okay, so it is not example for method overloading. Likewise, here second example or test method. So here the method name is similar, but the return type it is void. Okay, so here it is a static, both are different method type. So this is static method type, this is normal method type, so it is also not a example for polymorphism. And another one is here method name is add, the class name is test. Okay, and the this class is end here. Okay, like that second class is defined with respect to this second class. Again we are having add, same integer a, here also integer a, but both methods are in different class, both methods are in different class, so which are not which are not similar to each other. Since both methods are defined in different methods, which is not example for the polymorphism. So whenever polymorphism we are implementing, the method should be available inside the same class with the different name of the method, I mean with the same name of the method and different number of arguments or different type of the arguments. Here one example is given with respect to class animal. Then I am creating the method eat inside the animal class, which is having single statement to print the a label animal is eating. Then this animal class is ended here. Then I am creating the child class dog, extending the parent class animal, which is also having same method name like parent method eat, which is printing the different label dog is eating. Okay, then inside the child class dog, I am creating the main method. Then with respect to dog class, I am creating the object d1. Here the d1 is calling eat, so this d1 is called a static binding variable, because here also the dog class, here also we are creating constructor with respect to dog class, so it is called static binding. So static binding will be done during the compilation time. Okay, so d1 eat dot eat, so which is, you see, this both are having same method name, both are having same method name. So here this is calling the eat method, so here this one is overriding the parent method. Like that second one is, here we are creating dynamic binding variable. Here the dog is the constructor with the object is created with respect to animal class, parent class, so this is called dynamic binding. So here this variable is calling the eat method. Here this is belongs to here the dynamic binding variable. The output of this program is here the dog is eating for this particular d1 object method calling, and a dot eat method calling is here dog is eating. That means this is overriding this parent class eat method. So this is the polymorphism implementation by using the Java programming. With when we are having two methods with the same name, either inside the same class or in the parent class and subclass. So that's what here we have given the definition, right? The polymorphism can be inside the parent class that method will be available in the parent class or child class. So based upon that, here which is performing the overriding when we are having two methods are having same name. Okay, and here the method overriding is linking the method call and implementation, which is resolved during the runtime. If method is in subclass which is containing the same method name in a superclass, then method in the subclass is overriding the method in the superclass. That's what we have seen in the previous slide. The subclass method is overriding the superclass method eat. Okay, when an overridden method is called from an object of the subclass, it is always referencing the method which is defined in the subclass. That means whenever we are calling the method eat, either using the static binding or dynamic binding, with the subclass is overriding the subclass method is overriding the parent class method. Same method defined in superclass which is hidden behind the subclass method, or which is called technical name is overridden. Rules for the method overriding is here the methods should have same number of arguments, and they must have same return type, and return type in the sense here integer method name add, then here like this. Okay, and another method also should have same return type integer add, but different arguments inside the method call, inside the argument list. Okay, and also the methods must not have a more restrictive access specifier. That means restrictive access specifiers are here final, private, so static. So these are all restrict access specifier. So these methods cannot be overridden. They must have less restrictive access specifier like public, protect, right? So like that it should be a less restrictive access specifier. And the methods must not throw new or broader checked exceptions. It should throw fewer or narrower checked exceptions or any unchecked exceptions. This will see we will see in the forthcoming modules. Then final methods also cannot be overridden. That's what we have seen here. So here the example for method overriding, subclass is having the method add which is overriding the superclass method add. In this example the class name is addition which is having the method name is add. There is no arguments, right, which is printing the value the add in superclass. Then we are creating the method sum which is the extension of the parent class addition, which is also having same method name add. There is no arguments. Okay, so parent class also having the add method with the same type. Okay, both are void, and this is printing the value add in subclass. Now driver class is created. Here I am creating the method, object with respect to the class sum. Sum is the child class, so this is static binding. So both side class names are same. Then I am calling the method by using the object by using static binding. When you are calling this child class is overriding the parent class value as per this statement here, right? So when the subclass method is overriding the method in superclass, so here this is taking charge. Okay, so it will taking charge, and this will be hiding behind this child class method name. So we will get the output as a this statement which is available inside the child class method. Why do we need method overriding? Overridden methods in a class hierarchy is successfully applying the polymorphism that the superclass and subclasses form a hierarchy. That means which one will be called first, which one will be called second, like that here, which is moving from lesser to greater specialization. That means subclass is taking charge, okay, and superclass method is hiding behind the subclasses method. The superclass provides all the elements that subclass can use directly, right? So facilities and features can be used by subclasses, that means child classes, directly. It also declares those methods that subclass must implement on its own. That means you see the methods available inside the parent class also implemented in the subclass methods. So then only we can apply the method overriding. Thanks for watching.